Hi folks, Joe here. In my previous videos I talked about the basic function of equalizers and also did a deep dive into how they actually work and what the pros and cons of each type of EQ are. Today I will be talking about the principles of how I myself apply EQ and the scientific basis for my choices. First off, let's talk about the biggest issues EQs are meant to solve. Masking. Masking occurs when one or more elements in your mix tries to occupy the same place and becomes a jumbled mess. There can be different types of masking: temporal and frequency-based masking. Temporal masking happens when an overpowering element masks another element in time. If the masked element is before the masker, it is called backwards masking. If it is after, it is called forward masking. Usually, a heavy hit from a percussive instrument will do just this. Frequency-based masking occurs when an element attempts to occupy the same frequency domain as another element. Some elements that are relatively in the same frequency band can also mask each other, even if they are not exactly at the same frequency. But why does this happen? To answer this, we have to look at the most important device most of us already have since our birth: our ears. Let's see how they work. Sound waves are basically vibrations in the air. The pinna and ear canal, located in the outer ear, are responsible for collecting these vibrations. They then forward these vibrations to your eardrum, which they hit, and behind the eardrum there are three tiny bones: the hammer, the anvil, and the stirrup, that transfer and amplify these vibrations into the cochlea, a snail-shaped structure that contains hair cells that convert these vibrations into nerve signals. Now, the fun part. The hair cells in your cochlea can be divided into multiple parts that are responsible for picking up different frequency bands. This means that if an element is too close to another element and is located in the same critical band the hair cells pick up on, the cochlea will not be able to differentiate between the two. This means that when using an EQ, one should keep a mental note of the critical bands. Subsequently, room can be made for each instrument in each of these bands. You don't have to know these critical bands by heart, but what you should know is that at lower frequencies, these critical bands tend to be relatively wider. This is why the band between 200 Hz and 400 Hz is critical, and why most engineers tell you that this is where mud resides. Now, let's see how we EQ according to these principles in practice. Let us now examine the spectrum analyzer in ProQ4. In our case, we have a pluck and a pad. As you can see, the fundamentals of each instrument overlap. The result is that you can't really make out what each of them is trying to play. This can be addressed in multiple ways. If you have the option, altering the arrangement is your best way to go. By shifting the pluck up an octave, both occupy a space that is currently free. However, sometimes you may not have any control over the arrangement. Another way to make way for the plug is to attenuate the clashing frequencies in the pad. This way, the plug gets more room to breathe. These kinds of EQ moves might sound really bad when you solo, though, so always keep in mind that context is very important. Another more sophisticated way to create space for your plug, while conserving the mid-energy of the pad, is to use a sidechained dynamic EQ. Dynamic EQs attenuate or amplify bands when they reach a certain threshold. If you sidechain your plug, the EQ will only trigger when the sidechained signal hits the threshold. This method is great if you have an instrument that is really lush and you want to retain most of its power. I can also show you another example of a sidechain signal in a song I recorded with my own band.
Megadom magamat, megadom magamat, megadom magamat.
Of course, sometimes the best move you can make is none at all. Simply adjusting the volume knob can also be an efficient way to give priority to an element and push another one to the background. Thank you for watching, and if you liked my video, please like, subscribe, and hit the notification button. I will put links to my socials and my webpage in the description. Stay tuned, as I will be covering compressors, both digital and plug-in versions of analog ones, in my next videos. See you all next time.